Good evening, friends. Study with the Pala Engineering and General Geology Parvin Singh book. So in chapter 10 अपना नया टॉपिक है, इसी में ही फॉर्म द स्टडी ऑफ मिनरल्स में से एवरी क्रिस्टल सिस्टम्स सो टिपिकल ग्रुप ऑफ or groups of faces developed on individual crystal which besides occurring in an orderly manner so in identical mathematical relations with the crystallographic axis. Any group of similar faces showing identical mathematical relations with the crystallographic axis make a form. Obviously, minimum number of faces required to make a forms are two. In practice, forms having up to 24 and 48 faces are also known to occur. A crystal's meso development of only one forms, example cube, on it, or they may be a number of forms and occurring together, making the crystals a really beautiful natural creations. Forms are further distinguished into following types of holohedral forms, hemihedral forms, hemimorphic form, enantiomorphic forms, and then fundamental forms, and open and closed form. Holohedral forms, and it is that forms in a crystal systems which shows development of all the possible faces in its domain. And for instance, octahedrons is a holohedral forms, and because it show all the 8 faces developed on the crystals, and generally so holohedral forms develop in the crystals of highest symmetry in a crystal systems, such a class of a highest symmetry in a system is called its normal class. Hemihedral form, it shows as the name indicates, only the half the number of possible faces of a corresponding holohedral forms of the normal class of the same systems. As such, all hemihedral forms may be assumed to have been derived from holohedral forms. Holohedral forms and hemihedral forms and tetrahedrons and four faces derivatives, and hemimorphic forms and see top and bottom faces. Obviously, two complementary hemihedral forms and termed positive and negative or right and left will necessarily embrace all the faces and characters of the parent holohedral forms. Hemihedral forms developed due to decrease in the symmetry of a crystal. Example, octahedron is the holohedral forms and tetrahedrons only 4 faces in a hemihedral forms develop from it. It has only the 4 faces and occur in crystal of tetrahedrite class of isometric systems which has a lower symmetry and than normal class. Hemimorphic forms, it is also derived from the holohedral forms and has only half the number of faces, and in hemihedral forms it in this case, however, all the faces of the forms are developed only on one's extremity of the crystals being absent and from the other extremities. In other words, such crystals will not be symmetrical with the reference to a center of symmetry. Enantiomorphous forms. An enantiomorphous forms is composed of faces placed on two crystals of the same minerals in such a way that faces on one crystal becomes the mirror image of the forms of faces on the other crystal. Despite that each forms is independent, that is that though having an identical mathematical relationship of one from forms cannot be interchanged with its contour parts on the other crystals, as the right hand and the left hand having similar relation to the body axis are not interchangeable. So is the case within enantiomorphous forms. So the forms and the corresponding crystal swings, these forms are referred as left and right handed crystals of quartz. So best developed enantiomorphous forms. Enantiomorphous forms quartz Fundamental forms. It is also called a unit forms. It designated that type of any given forms in which the parameters essentially correspond to the assumed unit length of the crystallographic axis. Forms having a symbols 111 is essentially a fundamental forms, and whereas another forms also intercepting the three axes at a different length. Example 1 2 3 comma 2 1 3 and comma 3 2 1 is not a fundamental forms. Open and close forms. A forms is defined as the closed once on full development it make a fully enclosed solid. In an open form sense, space cannot be fully enclosed by it, and an entry from one and more sides is possible. Closed forms and open forms and crystal classes and systems. It has been observed that all the crystals of minerals and synthetic substances studied so far can be grouped on the basis of a symmetry into 32 classes. These are often called crystal classes, and by definitions all crystals with an external forms on the same symmetry make a crystals class. A detailed studies of all the crystals class is required only by a professional mineralogist and is beyond the scope of this book. All the crystals and hence the crystals class when referred to the crystallographic axis can be conveniently grouped into six major crystal systems. These systems in order to decreasing symmetry are in isometric cubic systems, hexagonal systems and tetragonal system, orthorhombic systems and monoclinic system, triclinic system. Of these, the hexagonal system is further divided into two divisions, the hexagonal division and the rhombohedral divisions. In common practice, study of crystallography is and involves referring and given crystals to the three or four into one case crystallographic axis, and thereby its crystals of system is found. Then its symmetry element are determined in in desired details to place it in a proper symmetry class. And so finally various forms develops on it are carefully studied, determining and parameter indices and symbols in each cases. In the following page, an attempt has been made to describe the silent features of the six crystallographic systems as briefly as possible and also in accordance with the set patterns. And for very detailed studies of the crystals characteristic of the symmetry class, the readers is referred to any standards book or crystallography. Thank you.